In this lecture, we discuss read-only memory, ROMs, and types of ROM memories. Now, in a previous lecture, we discussed SROMs and DRAMs, which are volatile memories. What is volatile memory? Lose the content when the power is turned off. But for many applications, need memory devices to retain the content after the power is turned off. So for example, if we are turning on the computer, then the operating system must be loaded from the hard disk into the memory. This is for this what booting program should be executed. Now to execute the booting program, few instructions should be loaded into the main memory. If complete main memory is a volatile memory, then these instructions are not executed. Thereby what operating system is not loaded into the main memory. Now for that we need a non-volatile memory. In that we need to store the few instructions which will execute the booting program. So what is non-volatile memory? Non-volatile memory, it will retain the content after the power is turned off. So for that we need a non-volatile memory. So ROM is also non-volatile memory. Now here reading operation of non-volatile memory is same as a volatile memory. But there is a separate writing process is needed to place the information in this memory. And there are different memories are there now that we are going to discuss. Now this is the ROM cell. If you observe this cell, it is having the bit line and word line. One transistor is connected. Now here, now it is almost like a dynamic RAM. Only here the capacitor is not available. But almost it is look like the same, and reading operation is same like a RAM. Now here, instead of a capacitor, here we have a permanent connection. Now the point P is connected to the ground by using this connection. If this transistor is connected to the ground means what? Whenever the word line is equal to 1, then on the bit line 0 will be appeared. Now if the transistor is acting like a closed switch, now this is connected to the ground, so 0 will be appeared. Now if this connection is not there means what? P is not connected to the ground, it is open, then it is nothing but what? Open means whenever word line is equal to 1, on the bit line logic 1 will be appear. So for logic 0 this connection should be there, for logic 1 this connection should be not there, means this P is not connected to the ground means what? Open. This connection should be open. So this is done at the time of manufacturing itself. Once at the time of manufacturing connections are made and connections are opened, then again we can't write the data into the ROM. So this is called the ROM, read only memory. We can't write the content again into the memory. So this is a, at the time of manufacture only the data are written into the cell. Now coming to the next type, programmable read-only memory, PROM, means what? Allow the data to be loaded by the user. Means what? A user can write the program one time. Now instead of this permanent connection, now here fuses are fuses are connected between this transistor to the ground in the complete memory. Now if I take the huge memory, now memory is arranged in the form of arrays. Already we have discussed in the last classes. Now these are the connections. Now here, if this transistor is connected like this, now this here fuses are provided and ground is connected. In between ground fuses are there. Now user can write the program to burn these fuse. If all the cells, this fuse is connected means what? Initially at the beginning, all cells are zeros. Now when the user writing the program, by writing the program, by allowing the excess current to this fuse means what? Fuse will be burned out and the logic 1 will be stored. So initially at the beginning, complete chip is stored with zeros. Wherever ones are needed to be stored, there by writing the program, user will write the program. By writing a program, excess current will be allowed through this fuse and fuse will be burned out. Thereby what? Logic 1 will be loaded into the cell. And once the fuse is burned out means what? We can't again make the connection. So this is irreversible. Only one time can be program written and we can't erase the program again. Now, next coming to the next one, erasable programmable read-only memory. Now here, instead of using the now single transistor program can be written and we can erase the program and we can rewrite the program. Now a permanent connection is made. Now this is a P, permanent connection is made to the ground, and here we are using a special transistor which transistor can act like a normal transistor and a disabled transistor. If it is acting like a normal transistor, now this point is connected to the ground, 0 will be available. And if it is acting like a disabled transistor, means a transistor itself act like a open switch and it is acts like a logic one. And how can this transistor act like a disable means what? Now this is the gate point. At the gate, by using a high voltage, by injecting the charge carriers between gate to the drain. So now the charge carriers are trapped between the gate and the drain. Thereby what? The transistor acts like a disable. Means what? Transistor acts like an open switch. So thereby what? If we are trying to read the content on this, it now here the transistor is open means what? One will be, now this point is not connected to the ground means what? One will be available on the bit line. So here in this erasable programmable read only memory, so programmer can write the data into the chip. So, and also whatever the program is written, that also can be erased. So that the data can be erased by using the UV light. Now, whatever the charge carriers are injected, that can be evaporated, or that charge carriers can be deleted by using the UV light, by exposing the UV light. Now, if this is a chip, one window will be provided on this chip, and through this window, if UV light is exposed, then the charge carriers which is trapped, the charge trapped in this transistor can be evaporated. So this is like this we can rewrite the program into the erasable programmable read only memory. Now next one is what? Electrically erasable programmable read only memory, or EEPROM, E square PROM. Now in a EPROM, now to erase the content, now that IC should be removed from the circuit and exposed to the UV light. Now in the case of electrically erasable means what? By writing a program itself, we can erase the content and we can rewrite the data. Now we no need to remove the IC from the circuit. Now for reading and writing and for erasing, three different voltages are used. By using three different voltages, we can read the content, we can write the content, and we can erase the content also. So this is the E square PROM by using the single transistor, same as a EEPROM. Now coming to the next one is a flash memories. Now here the approach is similar to the EEPROM, but only the difference is in the EEPROM. If the complete this is a memory, in this single cell can be read and single cell can be write. But coming to the flash memories, now the reading the content of a single cell is possible, but writing the content is possible only for the entire block of cells. So for that what? The entire block will be erased first and rewrite can be done. Now these flash devices are great density and high capacity and low storage cost, and power consumption of the flash memory is very low. Because of these these features, now these are more attractive for the equipment which are driven by the batteries. Now, like example, handheld computers, cell phones, MP3 players, and digital cameras, we will use the flash memories. Now, this flash memory for a single chip, the memory is not sufficient. That's why we need large memory modules which are implemented using the flash cards and flash drives. Now, flash card is nothing but what? Mounting these flash chips, large, mounting a few, so many flash chips on a single card. So thereby we are increasing the capacity of this flash memories. Now these are available in the range of 8 mega, 16 mega, and 64 megabyte. 64 megabyte. Now, by using 64 megabyte, we can store the 1 hour audio record. Now, these are the flash card. Now, coming to the flash drives. Now, if you say take the handheld computers and cell phones to operate the OS, now these flash drives are required. But coming to the now here, coming to the now these flash drives are used in place of hard disk, but still hard disks are having some advantages over flash drives. Now these flash drives we can operate by using the very less voltage. That's why we are using these flash drives to in a portable devices which are driven by the batteries. But coming to the hard disk, the few disadvantages are there. So for hard disk, now these flash drives are available only in the range of which are less than the 1 gigabyte. But coming to the hard disk, now hard disk, these are available in the range of few giga, many gigabytes. Now here gigabytes, many gigabytes. Now this is less than 1 gigabyte. And also here to store the now the cost per storage per cost per bit is less in the case of hard disk. Now in the flash memory it is little high compared to the hard disk. And these hard disk we can use for a million times to rewrite the content. But the flash memories, now here we have to replace uh, after it has been written a number of times. Now these are the disadvantages of flash drives over the hard disk. But coming to the flash drives, there are no movable part. That's why these flash drives are very fast compared to the hard disks. Now with this we finish the types of ROM memories.